let's get started. So my name is Farhad. I'm by training a librarian and by education, and I've started being involved in evidence synthesis 20 years ago with developing search strategies, and gradually I got involved in screening, data extraction, grading, risk of bias assessment, publishing. So I got involved in all of the aspects of evidence synthesis. And right now, my time is spread across these four organizations: University of Bristol, University of Oxford, Cambridge, and Systematic Review Consultants LTD. And what we do, we provide evidence synthesis services. So what I do at these organizations is to help with the evidence synthesis process from the beginning, from the development of the question and protocol until the publication. And if it is a living evidence synthesis, the future update searches and update evidence synthesis. And I've been involved in evidence synthesis with multiple organizations: governmental, pharmaceutical, device companies, governmental companies, academic companies, and also international organizations such as WHO, UN, and UNICEF. So I have a bit of experience in evidence synthesis and a bit of experience in using AI and ML. I don't consider myself artificial intelligence or machine learning expert. I consider myself a user of all the tools and methods. Why I suggested this session? The main reason was that I was seeing a lot of colleagues who were complaining about that there is a lot going on and we are missing out. And many of them say that everyone is using GPT or Claude and we are not using it. And we are worried that we stay behind. And this fear of missing out is a marketing strategy that actually have been used a lot of times before to push people to use these tools, because that is the purpose of these tools. The purpose of these tools right now, majority of them, are to convince us that they are great and we use it, because as we use it, they start learning from us and then they improve. So fear of missing out, or FOMO, is something that marketers are using against us. So don't worry, you are not missing a lot. There hasn't much changed. But I'm going to tell you why, where are we now and where are we going to be in the next few years. And then there is confusion as well, because many of us are not expert in AI. We are hearing all these terminology that have no idea about what are they. Should I learn about them? Should I drop everything and go for AI? And then the progress is rapid. You are hearing a lot in social media, in the media, about AI and machine learning. And we think that there is a huge impact is coming toward us. And if we don't catch up soon, we are going to stay behind. And then we need to plan for the future, because there is going to be change in the research, in policy and practice because of the introduction of these disruptive technologies. And then there is too much information. I have about 1,500 PDFs, just the PDFs. There are a lot of notes I've taken, a lot of other files like images that I haven't read. They are all related to my field and I need to find time to read them. So whenever I see a great one that has summarized, let's say 20, 30 of other research, I definitely read them. And I try to pass it on to the other community members as well. So I usually start with typology of artificial intelligence because I think it is helpful. And many of my colleagues have said that this is actually clarifying that it is not new. So we had automation and semi-automation since I remember, since I entered the university 20 years ago. We were using SPSS. We were using software programs for statistical analysis, which was fully automated. You enter the numbers and then you get the analysis done. So automation is not new. We had PubMed, Medline since a very long time ago, and we were entering the keywords and getting the list of papers, which is a sort of automation. So the automation and semi-automation were around, but the majority of the ones that we were using were the algorithmic if-then sort of automation. So it was sort of binary, and we are still using it. Whenever you ask EndNote, you select 250 records in EndNote, right-click and say that find PDF, and it start looking and finding the PDFs. That is if-then type of, or when you are using EndNote or other citation managers for deduplication, if these two records are duplicate, yes or no. So this sort of automation we also had for a very long time. It is not new. But the sort that is related to artificial intelligence, and I'm sorry that I'm calling it intelligence, because we don't have a better word, and it is sort of marketed to us to call it artificial intelligence. But that is what the computer scientists are using, and we are following them. So artificial intelligence started to be implemented in evidence synthesis for about 15 years ago. And we have two types of it. The type that is learning and the type that doesn't learn, and it is rule-based. The rule-based one, we've been forced to use it. So spam detectors, and let's say when your bank account blocks you or blocks your card, these are sort of the rule-based ones. So if they are suspicious, they just block you. If they are suspicious of an email, they just block it. So this is a rule-based one. We've been using it for a very long time again. And then the AI that learns. And the AI that learns, depending on the type of learning, we have two major types. The supervised one that learns from humans. So as you start doing the task, the machine looks at your actions and learns from it. And then it could start imitating what you were doing. And then based on that, as you proceed, the machine can reach a level that performs as good as or better than you or faster than you. So the performance for that specific tasks gets better because you are the teacher, machine is the student and learns from you. And then we have the unsupervised type, where we are presenting machine with a lot of data and asking it to learn. So if you want to have a good analog for this, is that when a student come to your office and ask for something, you guide them and they go away and come back again, and you guide them and you continue these supervisions until the output is complete, the dissertation is out. And then unsupervised one, the students come to your office and then you said that there is a library, go there and read every single book and then come back with the output. So that is unsupervised, you don't do much. So the student does most of the work. Some people call it self-supervised learning rather than unsupervised because the machine sort of supervises itself. And this is sort of new, but the supervised learning itself, the ones that we are using a lot, we are using a subtype of supervised learning called discriminative learning. And what it does is to look at the data, learns from human, and categorize or classifies the data. And the most famous one that we are using continuously is the RCT classifier that James Thomas and colleagues developed with collaboration with Cochrane. And what it does is it looks at the record. If it is RCT, it says that it is RCT. If it is not, it says that it isn't. And if it cannot decide, says that I cannot decide. You go ahead and screen the rest. So it categorizes, it classifies the data. And then with the unsupervised one, the famous one is the generative one, and the generative AI that can generate text, image, or video. So what we need to know is that actually the part that we are dealing with is the large language models. And as we say large because they have been pre-trained on a lot of text. So this training might not be supervised at all, or a little bit of supervision was done. So we say large and then we say language, which means we are dealing with the text and the language, textual data mainly, and the model, it means that this is a machine learning model. So the part of the generative AI that interests us in the evidence synthesis are the large language models. And this is new, the unsupervised generative AI large language models. The rest of what you see in this graph, we've been using for over 15 years. So we've been using AI machine learning for a long time. So here I'm going to present about both the supervised and unsupervised machine learning. I also will clarify some tips that is helpful for anyone who is a student, who is a librarian, who is evidence synthesizer, whomever is related to the systematic reviews and evidence synthesis. So if we start with a bit of background about the large language models, if you look at their terms and conditions, they specifically say that they are good for text generation, for translation, summarization, and question answering. So it is very important to remember that these models have been developed for these specific roles. And then they also say that never take advice from them and always double check the work that they've done. So where are we with using AI in evidence synthesis? I tried to shove everything in a single slide because otherwise there was no way that 1 hour could actually encompass all of this information. So we know that there is a research published in Annals of Internal Medicine showing that we can use large language models for finding PICO questions for the guideline and for regulatory purposes. Because now recently the changes in the regulatory of medications and medical devices asks the HTA agencies to look for existing or PICO questions of interest from multiple countries. So large language models are going to play a role in there because they can actually, if guided, they can access a lot of literature and then based on that extract the relevant PICO information or the evidence gap as well. For the search part, there has been great progress for scoping searches, scanning the literature and not necessarily the horizon scanning. Recommenders, so you say that these 2 papers are relevant, recommend me more relevant papers, and actually you can get, there are tools that will give you 10 more relevant papers. For mapping the literature, showing that what is around and what are they about. So that is something that we have a lot of tools for that. And then for the keyword collections and developing basic Boolean strings. Again, they are helpful. Large language models can help. Just to consider that when we are using large language models for developing search strategies for systematic searching, they are not going to perform well unless you are expert librarian or information specialist and you teach the machine what to do. Then they might be able to help you. And there is one aspect that they cannot actually help, and that is the controlled vocabulary. They tend to create the controlled vocabulary that does not exist. Some people call it hallucination, so giving you wrong information. They are not true. And then they cannot access the M3 terms. So even if you could use a method to feed all the mesh terms and ask large language models to give you the relevant mesh terms, because they cannot access M3, they cannot really create a controlled vocabulary. And because we are following the best practice in our field, that is the point that they are gonna stuck. But they can be time saving if you have a list of prompts already written, curated for collecting the keywords for each one of your concepts, and also for teaching the large language models what syntax to use, what is the truncation, what is the adjacency, what is the wildcard, what is the frequency. And then based on that, it can develop a basic search strategy and save you time. Another thing that, other than controlled vocabulary, another thing that the machine would struggle is to choose which one of the concepts to include in the search strategy or not. So the machine cannot decide which one of the concepts are search resistant. For example, we usually say when we are searching PICO, not to include outcomes, for example, if possible, and go for the problem and intervention mainly, because they are more visible in the literature. And machine cannot decide it. Again, you need to have the human input in there. But there is an aspect of search that has been automated in a few efforts successfully, and it will be automated in the future. And that is the automation of update searches, especially for the living evidence synthesis, living maps. And the reason that it works very well in this aspect is that we have already used it. So when you are already using it during the systematic review to train it what to do, it can learn from what you've done. And it can learn from the baseline searches and baseline screening, the first search that you've done, and then applies that learning for the update searches. And in that sense, it has successfully implemented by EPPI-Reviewer team in a few maps. And I have seen that they work completely efficiently without losing any relevant records. So still we require some validation, but that is the aspect that we will be able to see in the near future that is being automated or fully automated with human supervision, obviously. For the screening, it seems a supervised screening that we already had since 15 years ago. And the priority screening that implemented in the PRISMA 2020, 5 years ago, they are making a very good progress. And we are very hopeful that that progress continues because it has been validated, it has been researched. It is not something that is made up or created like the generative AI that each time that you ask the same thing, it answers differently. So this is something that we've been doing with human supervision and with a lot of control on it. And it is going to get better and better. So if you are using any automation tools, I would recommend you use the tools that are supporting priority screening or supervised screening. So they have machine learning model, they learn from your decisions and prioritize the records that are more relevant to be screened first. For the title and abstract screening that the LLM-based research are not showing that they are doing any better. So they may be 70%, 80% good. So they could detect that the accuracy is high, the sensitivity is good, the specificity is good, but it is not in a way that we could trust it for the systematic reviews when we require double checking and human supervision, and we shouldn't actually lose relevant records because even if you lose a single study or two studies, it can change the conclusion of the review. So for the general narrative literature review, it can be good because you can, if I'm a student doing a coursework, I'm okay with finding 70% of, let's say, literature in a few minutes by using one of these tools. But when it comes to systematic review, it is very important to have near 100%, let's say, inclusiveness of the relevant research. And I will tell you why it is not working and why none of the machine learnings, even the supervised one, are not working well for this screening. But there is an aspect of screening that machine learning models, supervised, unsupervised, are doing well and will continue to do well. And that is when we are dealing with the full text. And the main reason is that they have access to the full text. So all the required information for decision making. And that's why they can do better compared to the title and abstract screening, when sometimes we even don't have abstract. For assessing risk of bias, again, we already had machine learning tools. The most famous one, which is currently still available, I think one of the websites is down, but the second one is available, Robot Reviewer. Robot Reviewer can assess the risk of bias based on the Cochrane's risk of bias tool version 1 for 4 domains, and in 4 domains is as accurate as human, but much faster than human. So I have used it. We've published the first work that we published using this is 2020. It was for a scoping review of post-stroke fatigue that didn't require risk of bias assessment, but we did it because we had Robot Reviewer. And it showed that it works very well. And there are multiple research showing that it works very well. But now there is risk of bias 2 around, isn't it? So what to do with that? So right now, the only tool that I'm aware of that has implemented risk of bias 2 tool in the automation program and uses large language model to do the risk of bias for the researchers is the PICO Portal. And I will show you the example. So what it does, it gets the risk of bias domains, all of them, provides the answer or possible answer, highlights the text for you. So what you need to do when you click on that domain is to look at the section in the full text and then the answer. And if it is correct, you don't have to do anything. If it is not, you could change the answer. And this saves a lot of time. So it doesn't replace human judgment. It just automates the tasks that we used to do. We had to open the data extraction form. We we had to open the PDF, we had to use search function or scroll function to go to the section to find the domain item for the randomization, for blindness, for the reporting of outcomes. And then based on that, we had to make a decision. So what it does all of that, highlighting the section, and then even selecting the answer. So you don't have to do that extra click unless you want to change the decision. So we have great hope because right now it has been implemented in the beta version of one of the tools, but it's going to happen soon, and we are hopeful that it will actually happen, and that this tool will be able to do the risk of bias assessment for ROB1, ROB2, Robbins I as a minimum, but also for the assessment of risk of bias for the systematic reviews as well. And more tools can be implemented as we go ahead. So it is already there. It has already been implemented. It is not something to say that is it going to happen or not. It has already happened. And we will see it probably in next year, 2025. You will see it as part of a few of the tools, at least one of them, we are sure. For data extraction, we have had promising results with both machine learning and large language models. There will be missing data, there will be miscalculations that requires human check. It is expected, everybody knew that. But right now, Covidence is using large language model only for extracting interventions for now. There are other tools that are using it and they are extensively working on it. DistillerSR is working on it. I'm aware. I'm in touch with the CEOs of these programs just to keep up with all the progress and also report it back to the community. So I know that there are ASReview is working on it, and there are a few programs. So what you expect to see from next year is that these programs are going to announce that we have implemented large language model for the data extraction of at least clinical research studies, such as randomized controlled trials, non-randomized controlled trials. So it is coming, and we are going to see it next year, which is great. Some people are using large language models at the general tools like GPT Claude. They have had good results, but again, when it comes to data conversion, because we do have at least 21 occasions that we cannot have the ready data for the meta-analysis, and we need to convert the data to make it usable for the meta-analysis. So sometimes the standard error has been reported, not the standard deviation. Sometimes we have the quartiles, we don't have the data that we require. We don't have mean, we have median. So there are some sort of conversion that we need to do. Sometimes data is in figure, and even though some of these large language models can read the data in figures with 1 decimal, and we require usually 2 decimals, but not all of them can. So some of them actually have already implemented optical character recognition, OCR. So even if your PDF is scanned and you upload it, they will be able to recognize the text. But the research that have been done using large language models, they even get closer to 80%, 90% accuracy in the data. But when it comes to the numerical data that you need for the meta-analysis, they struggle. And that is because of the reporting, the bad reporting. So I wouldn't recommend using the large language models like general ones, GPT, Claude, but I would say if you are going to use it, make sure to learn from the prompt engineering of the existing research rather than reinventing the wheel, because then you would know what to write, how to instruct the GPT or Claude to do the work for you efficiently. So that is very important to save your time, not to reinvent the wheel. When it comes to the meta-analysis, we actually don't need to do anything with large language models or machine learning for the meta-analysis. And it is because we've got tools that are very efficient. We have statistical packages very efficient with 100% accuracy can deliver it. Because the large language models and general AI are based on probability and possibility of what word is going to follow the other word. So they are not really intelligence. What they are predicting that this word is more likely to be followed with the other word. And based on that possibility are giving you an answer. When it comes to meta-analysis, when we require accurate 100% accuracy, we usually don't need GPTs, but it is possible. So there are a few research published for meta-analysis and a couple published for network meta-analysis, showing that if you know how to instruct or how to prompt these machines to the language that they need to use, to the software. So you say that I want to do the analysis in the R, and using what package, the name of the package that they need to use in R or Python, and then give them the data in a format that is readable for the machine, they can actually conduct the meta-analysis and network meta-analysis. But it's not going to make much difference because we already have the best tools to do that. So we don't expect anything strange. What we can expect to see in this area would be more of knowing what comparisons are missing. So in that area, I think it's sort of scoping. So it could be considered as sort of scoping the literature rather than meta-analysis. But it can tell you what are the indirect comparisons, which are important if someone wants to run a clinical trial, if they want to know the evidence gap. So it can be useful for that sense. And if someone wants to do a network meta-analysis and needs to know what are the indirect comparisons. When it comes to the grade, as I mentioned before, for the risk of bias, we have high hopes. It's coming, it is already there, but it cannot. Machine learning and large language models, so supervised, unsupervised, they have difficulty in assessing the certainty of the evidence for the domains of indirectness, inconsistency, publication bias. So we don't have it there. So we still require human judgment, but it doesn't mean that it's not going to happen. I think with enough training, with enough data, it is possible to do the grading using large language models implemented in the existing tools. But right now we are not there yet. Probably in next 2-3 years, we are going to see development in that field. And I also need to mention that there are a few gaps. So we don't have enough research published on using large language models for the qualitative studies, even though some people have used it and reported some promising results, because that is what people report. Anyone who uses systems, they report the promising results. And if they fail, they never report it. So there is a reporting bias in there as well. But also there is another gap for realist reviews. So can I upload a PDF and ask for the large language model and to tell me the context mechanism outcome, for example, or context mechanism change that recently has introduced. So these are the gaps that we are still waiting for the research. We need to see more before recommending it to our users. But I want to focus here on the quality of input, because when it comes to using the systems, the large language models, and even the supervised machine learning that we use in Rayyan, Covidence, DistillerSR, EPPI-Reviewer, all of these tools. One is that the user's expertise is very important. So there is a golden rule. If you don't know how to do something, don't ask LLM to do it for you. Even though it's been said for the large language models, but it is true for the other. And I will show you how it can be true for the supervised machine learning as well, not just the generative unsupervised. So it is very important, if you want to do something serious, you should be an expert. So if you want to design a search strategy using large language models, you must be an expert librarian or information specialist. Otherwise, it's not going to work well. And that is the worry that we have now, that people are doing everything without having the expertise. It is the same for the data extraction, for the screening, for the meta-analysis, for the risk of bias assessment. So it is very important that use it if you are already expert, because then if it goes wrong, if it hallucinates, if it misses the data, then you would know because you are the expert. So the input number one is your expertise. So you input to the machine to produce an output, and the input number one is your expertise. Input number two is the file that you're uploading. And your file's quality is important. What do I mean by the quality? The format of the file that you are importing. If it is TXT, docx, HTML, textualized files, let's say, they will be performing better. PDFs depends on the quality, because Sometimes they get the numbers wrong because of the quality of the PDF. If they are scanned from the print copy multiple times, and sometimes it requires more attention and always requires double checking. So that's very important. The format of the file that you are uploading, they work, for example, for the translation, they work much better with the docx file than PDF file. Or with the HTML file. So if there is an article in Chinese and you have the HTML file, or you could convert the PDF to docx file, that is better for the translation rather than the PDF itself. And then if your input is a study and has multiple reports, it is better to put everything together, including appendix, into one file and upload it. Or if you're uploading as separate files, instruct and prompt the large language model that you are uploading multiple reports, but they are all belonging to the same study. Because otherwise it cannot, let's say, assess the risk of bias accurately. And the reason is that, for example, for assessing the risk of bias in outcome reporting, you need to access to the protocol that is pre-registered in ClinicalTrials.gov or published as a separate protocol, so that you see that the outcomes reported in the final report are the same that reported in the protocol. So, and the last one is for the screening. So if I'm going to screen each record, if I'm going to use machine learning for the screening, each record should contain title and abstract as the minimum. And it is very important. And it is important only if you want the machine to work up to the highest possible performance, obviously. If you don't care, having 80% machine working well, 20% you have to struggle and do it yourself, that's okay. But if you want to use the machine in up to the highest possible performance, then make sure that all your records have title and abstract. If they don't, try to find it. If you couldn't, try to screen the ones that don't have abstract manually, rather than feeding it to the machine. And I will show you example. And then the third input that you give to the machine are the prompts, the instruction that you are giving to the machine, the request that you are adding to the machine, that need to be reliable, repeatable, and tested, because this generative AI is good for creating new stuff. So if you ask the same question twice, 3 times, each time it will give you a new answer. So that negates the purpose of the reproducibility that is the prerequisite for any scientific research that we do. So if it is not reproducible, it is not research. And we are using these non-reproducible systems. What you need to do when you are doing the prompting, it is very important to give large language model a role. Tell GPT or Claude that you are a research assistant, you are a systematic reviewer, you are a biostatistician with 20 years of experience in prognostic modeling. So all of this will provide a context, and these large language models have context and have memory. So you can give these instructions step by step rather than all of them as one big chunk, and then specify the task that you want clearly with enough details. And sometimes if you give too much information, it actually messes it up. So you need to use the systems long enough, frequent enough to know how much information is good for them and how your wording could help. And then describe what you are uploading to the system. If it is RIS file, explain that it is RIS file and each one of the fields has been tagged and each one of the records have been separated by a space, or the records end with ER. So you need to explain that what file you are uploading, and then you need to explain what output you are expecting to receive from the large language model, exactly in text format, in any other format. And if possible, give the examples of the records that are relevant, the records that are irrelevant, and the edges or the tricky ones. So some people actually, what they do is that they give the edges and say that if you face the records that you cannot decide, it's not easy to decide, just consider them as included in the title and abstract screening. So you actually teach your research assistant. So your research assistant here is the large language model, is coming to your office. This research assistant is a student, undergraduate student. You try to teach them what to do accurately. And the problem with large language models is that if they struggle, they will not come back to you to say that I'm struggling. If your student struggles, they will come back to you and say that I cannot decide about this. So these large language models are confident and sometimes confidently wrong. So it is very important to consider this limitation. Even though many people call it a research assistant, I don't think they meet the criteria to become research assistant yet. Check the output all the time. Think why you receive this output and revise your prompts or file and repeat it. So you may need to do it a few times. And this learning part happens gradually over time. It's not going to happen in a day. We need to continue using these systems until we learn. And then report back to the community your experience, even if it is case study. I mean, majority of the work that we've seen so far are case studies using large language models, but each one of them have new learning point. If you look at the PDFs, the discussion, the limitations, conclusion of the papers, you will find something that you didn't know before. So it is important to report it, even if it is as a blog post. It's still useful. And these machines are here to semi-automate, and you always need to double check. So this is one of the export files that I got from ClinicalTrials.gov in RIS format, and then the same file that I export in CSV format. And what we see here is that in the RIS format, if you look at the fields that I've got, the only relevant field for the screening is the titles. So we have scientific title and the public title. There is no abstract in ClinicalTrials.gov. What do you expect from the machine? And then in CSV format, I noticed the typo, by the way. So in the CSV format, if you look at the fields, you're almost getting everything, but getting everything is not enough. You need to make sure this everything goes into the right field for the machine, and that is abstract. So if you get a RIS file, the machine is going to struggle when you are using machine learning, either the supervised, unsupervised. It doesn't matter because there is no abstract there. It cannot decide correctly. It will be confused. And then if you're getting the full records in CSV format, make sure they go into the right field so that the machine, or the field that actually machine can see and use. So this is an example. I was working on a systematic review of randomized controlled trials for schizophrenia. This is Rayyan, the old version. Actually, it is not available now, but I'm just showing you one of the records that is randomized. It's a randomized trial. It is about schizophrenia, and it is from ClinicalTrials.gov. It doesn't have abstract. And the machine's rating is 2.5 stars. It means it cannot decide if it is relevant or not. But obviously, a human looks at it and says it is relevant. So the machine learning struggles with the records from ClinicalTrials.gov for multiple reasons, because they are not standard records. Many of the machine learning models have been trained based on the journal articles that have title and abstract. So if we had abstract here, things might have changed. I haven't seen this happening, this occasion happening for the records with abstract, but I have seen it multiple times happening for the records without an abstract. As you know, in PRISMA 2020, we are able now exclude records without looking at them. And it is possible in certain occasions that I will explain. But usually, even though the machine detects records as ineligible or irrelevant, still it can be checked by at least one reviewer. So this is Covidence. Yesterday I took the print screen, so it is new. So there are two options when you are creating here. I'm just trying to highlight the section. Two options that you could choose when you are creating a project. And it says that use Cochrane RCT classifier to tag the references reporting on RCT. So it marks them as RCT, and remove the references that are not RCT. And there is something to know about these machines. And that is, they are very good at detecting negative records. They are very good at detecting negative cases. So if you see there are lots of diagnostic apps out there that you go to Spain, you return, there is a mole on your skin, you take a photo of it with the app and it tells you go to doctor or not. And whenever they say not, they are almost 100% accurate and more accurate than doctors. So they are very good at detecting the negative cases. So I would trust the second option. The first option, because they are being tagged, again, you could double check it. It doesn't replace the human judgment. It just helps you. So I used it for one of the projects. Here, you can see that we have had 2,700 duplicate records. We also have 2,400 auto-marked as ineligible. And then we have records that have been marked, obviously, as the randomized control trials, which are going to be here for the screener. But it did it automatically, and it will save you 2 days. I mean, if you're using double screeners, it's going to be 4 days of their time saved at least. So when to stop screening, if that is possible, to use the machine learning for the screening, how much screening is enough, and when I can stop the screening. So there are multiple studies published on this. We don't have one size fit all, but some of these programs provide you with something, we call it progress graph. And the progress graph can tell you when to stop. So what happens is that in the random, so if you don't use machine learning, you continue screening normally. That is how you identify. So that's the number of records you screen and the number of relevant ones you identify. And this is how long it takes to find all the relevant records. It takes, let's say, if there are 5,000 records, it takes 4,800 until you find all the records. So you need to screen all of it. But when you use priority screening, so the machine learns from your screening and shows you the relevant records on top. So you screen the relevant records based on the machine learning before the other records. And you can see that after about 600, the graph goes flat. It means if you continue screening, you don't include anything relevant. So it means that you can stop, or you can switch from 2 reviewers to 1 reviewer to save time. But these stopping rules, there are still research going on them, but it is possible in many cases that if you are doing a scoping review or evidence map or evidence gap, it is possible actually stop here and don't look at the rest. You are not doing this sort of work to deal with the human health outcome. It's not going to affect anyone's health. You want to scope the literature. So maybe at 1200, you could stop. If you are doing a systematic review, you could switch to 1 person and go ahead. And this is not a rule. Suddenly, that 1 person may detect 2 more relevant records here. Then you could switch back to 2 reviewers. But if that 1 person doesn't detect anything, then you don't have to involve 2 people. So that is saving the time and resources for the review. And we have also some of other features. Let's say in Covidence, we also have this feature here, most relevant, that allows you to screen the relevant records first. And that is also time saving. We have similar function in multiple automation programs. I'm just giving you the Covidence because I just had access to it and I'm using it frequently at my work. And then this is one of the greatest progresses that we had. This is PICO Portal. It has ROB2 implemented inside the program. So if you click on allocation concealment here, it will open the PDF, it will show you the highlight, and it has already made the decision. So what you need to do is to change the decision, add a note if you want, or just go to the next item. So you see how much time is saved with just the risk of bias assessment. So it doesn't replace the human, it just help you with automating some of the repetitive tasks like double-clicking, opening, browsing, searching to find this. And the highlights that usually are called as attention maps in the language, let's say machine learning and large language models, is helpful for you because you don't have to spend time for looking for this information. What you need to know: choose the right tool. That is the most important thing. Don't go to GPT Claude for everything. There are more efficient tools out there. There are lots of great tools for the search, for the screening, for data extraction that could help you better than general large language model chatbots. Just because the research shows that it works, it doesn't mean that it will. If you look at the research done and the team who did that research, the number of people involved, their expertise, if we can reproduce that team then and follow that protocol, we will be able to reproduce those results. Otherwise, they are just case studies. And then research has taken months to be conducted. Usually people who are using these tools want to do everything in a day, and it's not going to work. And finally, tech develops. Reproducibility is not something that large language models are interested in. So each time they are creative, creating new information, new answers. And then we don't actually know what is behind many of these tools. So we don't know how they've been trained, and if we could trust their training. And they are not transparent, they are not releasing it for the commercial purposes. And you could guess that there might be something that they don't want to tell people, including using copyrighted information when they were training their models. And now many of the systems, including Covidence, clarifies that even though we are using large language model to extract intervention, we are not using the PDF that you've uploaded to train this model. Because as soon as they do, it could be a breach of copyright. Prompt engineering is important. I'm working on another session on prompt engineering. Hopefully next year I will present it. I will focus on data extraction more than anything else, because I think that is something that people want to learn about. Learn about typology of prompts, and also remember that garbage in, garbage out. The general rule that the quality of output is dependent on the quality of input. Have no trust in any of the tools that you are using. Test it, validate it, make sure that you know what they are good for, and then read the existing guidance. We have nice position statement, and we have RAISE that is in development, but it is on OSF, openly accessible for you to comment on before the final version comes along. And then we have high hopes for the RAG, Retrieval-Augmented Generation. When you're asking a question from large language models, they go all over the place. But if you could upload a PDF, upload a file, and limit their function, the great performance to that file, that is specific source, it is great. If you could limit it to a database, it is great. So it is called Retrieval-Augmented Generation, and I'm going to London next week just to learn about this, because I think it is going to be game-changing for the systematic reviews, a game-changing tool. And then humanities are 2 decades behind science and tech. It is generally known that we will have the regulations probably in 2040 about the AI, and by then they have used a lot of copyrighted stuff, a lot of our resources without letting us know, without having our informed consent to learn from. And then the environmental impact of each time that we are using these models and the contribution to the global warming. When you are choosing a program for your library, for yourself, consider that you need to have a toolbox, not just a tool. So have a list of tools. Don't be loyal to one of these programs, because they develop and some of them becomes better than the others as you go ahead. You need to have project management skills. You need to have data management plan, and save the copies of the files and the records somewhere outside these programs. It is very important. So in case you decide to change the program, there is no easy way. They are not talking to each other. So if you want to switch from Covidence to Rayyan, or from Rayyan to DistillerSR, so there is no direct connection. So you need to download and upload the file. So it is really important to bear in mind how you are managing your data and files outside these programs. Have these standards of procedure in place. It will tell your students, yourself, your colleagues, when to go for what program, when to go for what guidance, and how to use them. And then consider the cost of the programs. And if possible, have a consortium across libraries when you are subscribing to these programs, because some of them are really expensive. And we need to consider to have a collaboration across the universities or across libraries to get subscription to them, negotiate for the lower cost, and ask for their refund policy that usually none of them have. Ask them, what if you want to change the program? Are they going to help you to switch from one of the programs to the other one if you want to leave them? And what happens if you no longer can pay the subscription? What will happen to the project? Do they archive them, delete them, or allow you to access them without allowing you to change them? And don't start any serious project when you are using free trial period. I have seen colleagues who stuck with the program because they advertised it, people started using it, and suddenly the free trial came to end and they had no choice but to pay. So that is something to consider. Customer services, if how long does it take for them to answer when you're having a query? How is the user friendliness, user experience, and user interface? What stages of review they support? What automation features they have for each one of these stages of the review? And do they support living evidence synthesis? So you want to use it forever. How it's going to work? And do they support the priority screening? And if so, what is their recommended stopping rules or process? The future is going to be great. We are going to have steady and slow progress. The main reason for the slow adoption of these technologies is that people have no guide. They are trying to self-learn everything, and they are not familiar with the technology. They fear that they are going to lose their jobs, and they don't have time to validate. So tech will become more and more efficient. It will become part of our usual daily use. We are going to use these automation tools more and more, but the traditional systematic reviews are going to survive. And the reason is that many people cannot afford to pay. Many people cannot learn because they become more and more complex. So the traditional systematic review is going to survive in parallel, and many countries cannot actually afford to pay. So what you see here is the innovation adoption life cycle, or diffusion of innovation model, that shows that innovators start any sort of new programs, new tools, and then there are early adopters who want to be on top, so they start using them ahead of the others. And then there is early majority, there is late majority, and then there is laggards. The only thing that changes here is how long does it take, this process, to everybody becomes the adopter. And it could be years, and it could be decades. How to stay up to date? Follow the colleagues who are up to date. I recommend following Aaron Tay on X, Twitter, and his blog is great for the search and discovery tools, scoping tools, mapping tools. Follow Professor James Thomas for the priority screening, auto update search and mapping, evidence mapping, great stuff. And also follow the progress with this automation program, because they are doing great things with the large language models, these 5 programs in particular. And we expect to see 2025 is going to be a year that they're going to release some of the capabilities that are going to be surprisingly good. Attend the webinars regularly. I've created a free newsletter to subscribe if you are interested. I cannot see your name when you subscribe. I cannot see your email when you subscribe. And you will receive the most recent publications from PubMed, between 1 to 10 publications every Sunday morning. So it is free to subscribe, and I have already done 8 issues. So it means that it's going to continue. We also have a YouTube channel that we are sharing every one of the meetings that we have. In this YouTube channel, we are going to share a lot of good information from the leaders of these technologies soon. It is planned. We are going to have a lot of unique information, and it is our serious strategy to have a lot of great content in this channel soon. And then there's going to be more webinars. I will certainly keep you updated on the social media, and I thank you for your attention. I don't know how much. Oh, 2 minutes. I will try to look at a few of the questions that you've asked. Thank you for your time, and thank you for posting 25 here. Oh God, there has been a lot of discussions here. Yes, some of you have introduced new tools. Cinema is an alternative grade for yes. Thank you, Georgia. I will keep I will keep talking about cinema, which is the best one I've heard from my colleagues for the network meta-analysis. Yes, we discussed the copyright restriction. The thing is that there is restriction on copyright, but who cares? I mean, people keep sharing their papers on ResearchGate. No one would know if you upload a copyrighted file into GPT. And that is the concern. That's why James Thomas and colleagues started to develop this responsible use of AI, the RAISE guidance, because many people would use these tools for search, for systematic, for screening without even reporting it. So we try to tell people to be ethical, to be responsible and report it. Yes, thank you, Carol, for sharing the robot reviewer. It is a fantastic tool. Definitely try it. I will share the another website. Definitely, Rachel, thank you. Your team is working on. Thank you, Carol. I didn't know. I will definitely have a look at that. And then we have, yes, that is the reproducibility is a serious issue. And yes, confidently wrong. Yes, we've seen that. So I recommend people usually not to ask any question with assumption from large language models. We used to have it with Google. I mean, we call it confirmation bias. If you tell Google or large language model that milk is bad, it will give you 10 reasons that it is bad. Ask them, milk is good. It will give you the reasons that it is good. So that is one thing. And remember, to become a good writer, you need to read a lot. And these large language models have read a lot. So they are very good at writing tasks. And if they hallucinate, it's okay because you're going to read the output and you're going to detect it. The issue is with the reading, asking them to do the reading tasks, including data extraction. And that's why this RAG is going to be important, the retrieval-augmented generation. Because right now, if it hallucinates during reading a PDF, you have no way to know unless you go to the PDF and read it. So Carol asks if PICO Portal is free. It has a free version. You could create one project with one reviewer, just play with it. But if you want to see the full potential, I would say many of them would require payment. And that is one of the reasons people are using GPT and Claude, because majority of these tools are not free. Yes, I use Covidence, I use PICO Portal, Rayyan, DistillerSR, ASReview. I mean, it depends on the team. That's why I say that you need to have toolbox. Don't be loyal to one of them. And I use Rayyan still more than others because many of the projects, they don't have funding, and they don't, when they are applying for funding, they forget to cost in the software program that they're going to use. And that's why they have to use Rayyan. So many people are still using Rayyan. Rayyan is indefinitely free. You could have many projects for free, but you could only have 3 projects actively at a time. Shouldn't be. Yes, many are focusing on PICO, unfortunately, because money is in PICO, and because pharmaceutical companies wants that, regulatory bodies wants that, device companies wants that, clinical scientists, clinical researchers, and patients wants that. That's why many are focusing on the PICO. But when we say PICO, we mean other frameworks as well. As long as you could explain it to the machine with your prompts, it can deal with any framework. For free tools for the priority screening, I would say right now, PICO Portal, you can use it for the priority screening. You can use Covidence. You can use Rayyan, but it will not show you. Rayyan and Covidence don't show you the progress graph. So you need to bear in mind that if I continue screening like this after 50, 100, and I see no relevant records after turning on the relevancy rank, obviously, then you could stop and switch from 2 reviewers to 1 reviewer. I will definitely share the slides. I didn't know that. I mean, my slides are boring, but definitely. PDFs are not used for training screening. What about data extraction? Yes, that is the restriction that many people would go around without reporting. Yes, unfortunately, we shouldn't upload the copyrighted PDFs, but many people do, and yeah. I mean, there should be a mechanism in this GPT and Claude to detect that this is copyrighted. I couldn't do anything with it. But no, they wouldn't do that because what they do, because they did unsupervised learning, to compensate to that, they released their program for free. Why? Because if they wanted to train it using human, they had to pay them. But now we are training these large language models, what is called reinforced learning or reinforcement learning. So what we do, we are training these large language models for them for free because each time that they do something wrong, we tell them you did it wrong, and each time they do right, we say thank you, and that is reward-based learning. And each time that we use them, we actually help the system to develop. Yes, thank you, Shahryar, for introducing Luna Lens. John, yes, there are studies published showing the sensitivity and specificity. There are some published for these developing search strategies for screening and for data extraction. And there are a lot of them actually. I probably have like 100 of studies that are reporting on the automation. The unsupervised one, probably there are about 50 studies at least published. Many of them go for the data extraction and the screening. I mean, if you subscribe to the newsletter, you will continuously receive the ones that are being published. Nested knowledge also had an abstract, at least. Yes. Yes, there are lots of tools. Laser.ai. Yes, I see them on LinkedIn. They are climbing up. I need to see the videos of them in 5-minute videos of each one of these tools posted on LinkedIn and YouTube, telling people what they are capable of. I mean, 1 hour webinars make people really tired. I can see that here. Equity of access to the, yes, I agree. I agree. Many higher education cannot access to these tools. Libraries need to do sacrifices. They don't have much budgets. Departments sometimes get the subscription rather than libraries. Indico. Well, that's new, Chris. Thank you for sharing with us. You see, there are so many tools. No one can claim that they can stay up to date. Thank you for joining us. Very much appreciate your time, and I hope that you had just a bit of new information that you didn't have before. Definitely follow our YouTube channel. You are going to see great contents, not by me. I know that I had enough. I think I have nothing to share with you anymore, but you will have content coming from the top tech developers and top evidence synthesis people in this channel. And it has been arranged. I appreciate your time. I will email you the link for the slides. I will email you the recording link, and I appreciate your support. And stay in touch if there's anything that I can do to help. Have a lovely day, have a lovely morning, lovely afternoon, and a great evening. Thank you and goodbye.